Let us see now the formal methods for our techniques for the precise and unambiguous specification of software. How should we specify the software model, or how should we specify the designs of the software, and how should we specify the each part of the software model? So there are formal methods which are there, and the first is formal specification, second is specification analysis and proof, and transformational development and program verifications. The language for formal specification has to have a precise and unambiguous syntax and semantics. So we will proceed with the next part, where the mathematical representation of software. How can you represent the software in terms of the mathematics now? So the we have already seen the software modeling design, where we have seen thoroughly the all the diagrams. Now with the diagrams, how can you convert it to the formal specifications? We will see now. The formal specifications are expressed in a mathematical notation with a precisely defined vocabulary, syntax and semantics. And algebraic approach is there. The system is specified in terms of its operations and their relationships. So model based approach is also there. The system is specified in terms of state model that is constructed using mathematical constructs such as sets and sequences. So there are two approaches: algebraic approaches and model based approach. So we'll see now the finite automata. The finite automata is the defined as we might have seen it in the theory of computer science also, in the discrete structures also. This is a queue, the finite set of states, where the number of states are there. Any procedure, if you take it, the procedures will be having a various actions, and actions how to do the transitions from one event to the another event, and that is due to the transition from one state to the another state. So the I is a finite set of inputs and then finite set of state, that is Q, and state transition function is nothing but the you are having a conditional product of Q, where the finite set of states into the finite set of inputs will be there, and that will be the transition state. So lights are on, lights are off. So if you push a light switch, then it will be on, and if it put light switch, and then it will go to the state off. So this is a transition between the one state to the another state. Only the one event is there where we can see that the lights are going to be on or off. So we have got now, this is the initial state and final state. Now Q0 is initial state, and F is nothing but the set of final states. There may be various final states also. There may be one or two or more than that also. The sequence of inputs is accepted by automation when a final state is reached from the initial state. So where we can have a plug here and unplug. Okay, the initial state is the plugging is there, and if you unplug, then the final state it will go into the final state. So push and push the light and switch and on is this is okay. This is safe one, but unplug is a final state where the unsafe final will be there. So if you unplug it, it will go to the lights are on. If you are unplugging the states, then unplugging the switches, then that will be dangerous for us. So this is an example of that is the finite automata, where you can also say the transition diagram, where Q is initial, login dialog, authentication, success or failed. Now you can see now I contains the states login, enter, cancel, accepted and decline. So there is a transition, that is delta 1, delta 2, delta 3 and delta 4 and delta 5. So this is a transition. Initial is if you transition, initial state is there. If you go to the login dialog, then you have to have a state that is called as a login, that is the input to you. So same thing happens, login dialog and cancel, failed, login dialog and enter, authentication, login dialog, authentication accepted or authentication declined, and Q0 is the initial state, and final state will be the either a success or failed. So sequence of inputs are the login, enter, accepted is correct, as well as login, enter and decline, cancel. Not acceptable is a login and enter. This is a simple example where you can see that the login behavior is being observed through the state diagram. So the key issues now, the formal methods reduce the number of errors in the software, but the mathematical representation requires more time to market the software product. Formal methods are hard to scale up to large systems. So the main area of their applicability is the critical systems. In this area, the use of formal methods seems to be cost effective. The idea is to combine the formal methods with the diagrammatical languages like UML, so that the formal methods will be used. So we have got a model-driven architectures. MDA is a framework that defines how model defined in one language can be transferred into the models into another language. So the software development process is driven by the activity of modeling of the software system. So MDA process is divided into three parts: build a model,